Hey guys, it's Dr. Cliff again, and I'm going to walk you through a crossover volume analysis problem or crossover point problem. This is probably one of the more complex type of problems that will work in this class, so it might take us a little bit, but we'll just kind of work through one step at a time, and I think it'll make sense when we see it one step at a time. So we're back to, I think I've told everyone, Mrs. Dr. Cliff is always wanting to start up this cupcake factory. She's got an idea that she can compete with the Cake Boss, and we've got a couple of options, and that's what a crossover volume, a crossover point problem. There's always two options involved. Sometimes you'll hear this talk maybe referred to as a make-buy decision. So if you were deciding whether you were going to make something or whether you were going to buy it from somebody, you'd use the same type of analysis. Sometimes we'll do this when we're looking at two different suppliers. So we could buy from supplier A or buy from supplier B, trying to make a decision which one is better based on the volume. For this example, it's kind of like that, but we're looking at two different locations. So we've got all the information to put this cupcake factory in Dallas or all the information to put this cupcake factory in Nashville. And so the question is, where should we put this cupcake factory? And it's dependent on how many cupcakes she's going to sell. So this is a crossover point or crossover volume problem. Sometimes you also hear it referred to as a point of indifference, meaning it's like the point where I don't really care. And what we're going to see is that one of these locations is better for low volume, and we don't really know what low volume means right now, but at very low volume, one's going to be better. At very high volume, the other's going to be better. So somewhere in there's going to be this point of indifference where it doesn't matter, the costs are exactly the same. So let's get started with some of the information that we have to have. So again, we're looking at a Dallas location and a Nashville location. There's our two options. She sells cupcakes for the same amount no matter where they were made, and that would make sense. So it's $40 for a batch of cupcakes, whether they're made in Dallas or whether they're made in Nashville. These are these high-end kind of designer type cupcakes. All right, and then we got some fixed costs. So that's one of the keys to this crossover point or any of these cost volume analysis is that we have to know the exact fixed cost and we have to know the exact variable cost. So fixed costs in Dallas, you can see that we got a rent, property tax, and manager salaries, and same thing in Nashville, but obviously we got different numbers. And so the first thing I want to do is figure out, well, what's the total fixed cost in each one of these two locations? So I'm going to use auto sum over here and make sure that I get the sum from B7 to B9. So I look at my little highlighted area and say, yep, that's what I want. So fixed costs per month, every month that she has this cupcake factory in Dallas, there's $6,650 worth of cost, no matter how many cupcakes she makes. The rent doesn't go up or down. Property taxes, manager salaries don't go up and down based on the number of cupcakes she makes. And then we're going to do the same thing in Nashville. So we can see right off the bat, Nashville has much lower fixed cost. So everything is cheaper in Nashville than it is in Dallas. Rent, property tax, and manager salary are all less per month in Nashville than it is in Dallas. Then we got some variable costs, and these are the costs that change based on the number of cupcakes she makes. So there's the ingredients, the flour and the butter and the sugar and all that good stuff. The labor for the people that are actually in this factory making the cupcakes, and the utilities to run all the ovens and the equipment. And that's based on cost per batch. So that should make sense. Variable cost, the more cupcakes she makes, the more money she spends on ingredients and labor and utilities. Whereas the fixed cost, again, we said it doesn't matter how many cupcakes she makes. So again, we need a total. Let me use auto sum. And I see that in Dallas, it's $14 per batch, and in Nashville, it's $17 per batch. And before we kind of get into the formulas, we can just kind of look at this and think intuitively for a minute. If she only made one batch of cupcakes, then you'd only have the $17 in Nashville or the $14 in Dallas. It's really the fixed cost that would be the determining factor. I would want the lowest fixed cost because in Nashville, one batch of cupcakes is going to be $4,025 plus $17. And in Dallas, it's $6,650 plus $14. So clearly, Nashville would be better at a real low volume. So I know real low volume, Nashville is my best choice. I can look at these difference in variable costs and figure at some point, if I was making 1 million batches of cupcakes, then clearly 14 times 1 million versus 17 times 1 million, I'd have $14 million in Dallas. That's going to be better. That's going to be a lower cost. And it's like the fixed cost doesn't matter. So I know for real low volume, Nashville is better. I know for super, super high volume, Dallas is better. And this crossover point is going to help us figure out, well, where does it change from Nashville being best to Dallas being best? And over here we got a little formula that tells us how to do that. And all we've got to do is take the difference in the fixed cost. So I have fixed cost number 2 minus fixed cost number 1 divided by the difference in the variable cost. And that variable cost 1 minus variable cost 2. You might notice that we say 2 minus 1 on top and 1 minus 2 on the bottom. That's just so I can keep all the numbers positive. You're really just looking for the difference. It's like an absolute value of the difference. So difference in fixed cost divided by difference in variable cost. That'll tell us our crossover point. But before I do that, I just want to get a little extra information here that we don't necessarily need to solve this particular problem. But I do want to figure out what's the break-even point in Dallas, because we've already looked at that. We've studied that in a couple different classes. If I'm in Dallas, how many cupcakes do I have to sell in order to break even? Because I got this $6,650 worth of fixed cost. So let's see, if I go back and look at my formula, I need my fixed cost divided by the price minus the variable cost. So let's just see how many we got to sell. I need my fixed cost, $6,650, divided by the sale price of 40 minus the variable cost of 14. So that tells me that if I'm in Dallas, I got to sell 255 batches of cupcakes every month just in order to break even. And I'm going to do the same thing for Nashville, same type of formula. So Nashville, I got to only have to sell 175 batches. That still doesn't tell me anything about the crossover point, but it does give me some idea about how much volume I have to do in order to make any money. So I'm going to take a look here. Rather than figuring the crossover point right from the beginning, I just want to see at different volume levels, a different number of batches, what's the cost in Dallas and what's the cost in Nashville? And I'm not really worried about profit right here. I just want to see what the cost is. So we should be able to figure out the cost for 100 cupcakes or 100 batches of cupcakes. It's the fixed cost plus that $14 per batch times the number of batches. And I'm going to copy this formula down, so we have to remember this absolute and relative formatting, referencing, because I've got my fixed cost here from B10. When I copy that down, I don't want that 10 to move. So I'm going to put the little dollar sign in front of that. And I got my variable costs in B16. I want to put my little dollar sign. I could have used the F4 function. So it's $8,050 for 100 batches. And then I can see my cost for anything from 100 to 1,500 batches. And then my formula, total cost for Nashville. So again, we said it's the fixed cost. And remember, we needed to use absolute referencing, so I'm going to use the F4 function, which puts the dollar signs in like I needed, plus the variable cost of 17, again, F4 function, and I'm going to multiply that by the 100 batches, and I can copy that formula down. And now I can just kind of look at it a little bit, and I can see, well, which ones, because we're talking about cost, I want lowest cost. So where's the lowest cost between the two locations? Well, when we first started this, we said, oh, if we only did one batch, we knew that the low cost was going to be Nashville. And sure enough, at 100, the low cost is Nashville. And at 200, the low cost is Nashville. 300, 400, 500, let's see. When does Nashville not the low cost? Looks like Nashville's the low cost from 100 all the way up to 800. So I'm going to just highlight that. We'll highlight it green. Like that's the low cost. But then look what happens at 900 batches. The Dallas cost is actually a little bit lower. And at 1,000 and at 1,500. So without really working the formula, I can tell that my crossover point is going to be somewhere between 800 and 900. So anything 800 and below, Nashville's the better location. Anything 900 and above, Dallas is the better location. But I really want to know what's that point. Is it 850 or what's that number? So we go back to that formula that we had up here. It's just the differences in fixed cost divided by the differences in variable cost. So let's see if we can put that in. I want fixed cost 2 minus fixed cost 1. So fixed cost 2, which is Nashville, minus fixed cost 1, which is Dallas. And I want to divide that by variable cost 1, which was Dallas. And I need that parenthesis in there. Minus variable cost 2, which is Nashville. So again, we're just looking at the differences in fixed cost divided by the differences in variable cost. And I get 875, and so that's 875 batches. And that makes sense because we said we knew it's somewhere between 800 and 900. So at exactly 875 batches, then both costs should be equal. And I'm just going to check that out. I'm going to put 875. I know this is out of order, but I've already got a formula in here telling me what the cost is, and that looks right. So at 875, both locations have total cost of $18,900. That's why we call that the point of indifference. Indifference meaning I don't really care. I don't really care whether I'm in Dallas or I'm in Nashville if I'm going to make 875 batches a month because my total cost is going to be exactly the same. I'm going to do one other thing here, and I'm going to put a little graph. So let's see if we can graph this information. I'm going to insert, and I think I'm going to try this as maybe an XY graph with a line. And let's see. Does this thing look like it's telling us what we see in our chart or in our table? So Dallas is the blue line. Nashville is the orange line. This x-axis down here is the number of batches. And this y-axis over here is the cost. So I can see that at low volume, the low cost, I want low cost. So Nashville looks better. Yep, that looks right. Looks correct. And then all of a sudden at some point, the lines flip, they cross over, and Dallas becomes the low cost. And if I zoomed in there, I could see that where they cross over is at that point 875. So I'd clean this graph up, put some titles on the x-axis and the y-axis and the chart title, make everything look pretty. But the graph tells me exactly what the table told me. And what it tells me is that if I think that Mrs. Dr. Cliff is going to sell between 1 and 875 batches, then we should put this place in Nashville. Nashville's our best option. On the other hand, if we think that we're going to sell from 875 to more, however much more is, then batches, 875 batches, then we should put our cupcake factory in Dallas. So that's a crossover problem. I think I've got a similar problem, maybe a little bit more simple, that has to do with the printer. So we'll see if we can work on whether we should buy an inkjet printer or a laserjet printer, and I'll leave that one for you to solve. So this is Dr. Cliff, and I hope that helped.